Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 7 in the Broken Access Control module titled User ID Controlled by Request Parameter. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account, so to access the exercise, I'm going to click on Academy, go down, select the learning path, go down, select access control, and then go down to the 7th lab titled User ID Controlled by Request Parameter. Alright, let's get started. This lab has a horizontal privilege escalation vulnerability on the user account page. So horizontal privilege escalation means that you're able to compromise users of the same privilege level. To solve the lab, obtain the API key for the user Carlos and submit it as the solution. You can log into your own account using the following credentials, and we're giving credentials of a regular user. Alright, so the target goal over here is to obtain the API key for the user Carlos and submit it as a solution. And we're given credentials of a regular user account, so the idea is to exploit the horizontal privilege escalation vulnerability in order to access another user's account. Alright, let's get started. Now, this is the built-in browser in Burp, and so all my requests are already going through the Burp proxy. Alright, the first thing that we're going to do is we're going to log in with the regular account that we were given and just analyze how the application works. Hopefully, we'll be able to see a parameter where we could change it in order to escalate our privileges horizontally to the Carlos user. So here's the API key. It's available on the /myaccount page. So if we go to home over here, it leads us to the shopping page. If we go to my account, it leads us back to the my account page. Now notice over here, the request to the my account page takes an ID parameter and it takes in the username of the user. Now, this is definitely interacting with the backend, and if the application is not confirming on the backend that the session cookie that is assigned to this user over here is the same one as the user that is requested in the ID parameter, then we could potentially have a privilege escalation vulnerability. So let's send this to repeater and just hit send again. Now, when we're searching for API key over here, you could see the username is for the regular user that we're given. Now let's see if this is actually checked in the backend or if it's client controllable. Because again, if it's client controllable, then we should be able to request the ID of any user on the system. So we're trying for Carlos, hit send, I get a 200 OK. This is already a good sign. And if I look for the API key over here, you could see that the username is Carlos. And so we were able to simply access Carlos's account by changing this ID parameter over here. Now, you might be thinking that this is simple, but this is actually a vulnerability that I found in one of the applications that I've tested. It's been a while since I've found a vulnerability this simple, but I did find it in one of the applications. So this is definitely real world. So let's hit submit solution, enter it over here, hit OK. And here we go. It says, congratulations, you solved the lab. Okay, so we completed the exercise by exploiting the vulnerability manually. Now let's script it. As usual, the first thing we're going to do is import the requests library, the sys library, URL lib3, and the regex library. Next, we're going to disable TLS warnings. And then we're going to set our proxy setting because we want all of our requests to be sent to Burp just in case we need to see them in order to debug them. So HTTP 127.0.0.1, port 8080, and then HTTPS. Again, sent to HTTP 127.0.0.1, 8080. All right, this looks good. Next, let's create our main method. So if name is equal to main, then call the main method. And we'll define the main method right over here. So def main. And we're going to say if the length of the command line arguments is not equal to 2, then print the usage and example instructions. So we're going to say the name of the program and the URL. So this is just guiding the user on how to run the program because the user ran it incorrectly. And we'll also print example instructions just so that it's absolutely clear how to run the program. Again, name of the program, and then let's say the URL is www.example.com. And we take the name of the program from the command line argument. And then we end the program because the user ran it incorrectly. All right, this looks good. So it'll enter this part of the if statement if the user runs the program incorrectly, so with the incorrect number of arguments. Now let's assume the user ran it with the correct number of arguments. The first thing that we're going to do is create a sessions object. So requests.session. This will allow us to pass the cookies of the logged in user once we log in. Next, we're going to say URL is equal to sys.argv1. So we're taking that from the command line. And then we're going to call the function Carlos API key, which takes in the session object and the URL. And what that function is going to do is essentially exploit the broken access control vulnerability in order to extract the API key of the Carlos user. Okay. So let's implement that function right over here. So def Carlos API key, again, takes in the session object and the URL. Now, before we decide what we want to implement in this function, we need to understand how the application functions. So if we go back to proxy and then under HTTP history, when we were logging in, and notice over here we've got a post request, the post request takes in 3 parameters, the CSRF token, the username, and the password. Now, the username and the password we already know, but the CSRF parameter we need to take from the login page when it loads. So the page we need to take it from is this one right over here. So it'll be in the response, so CSRF over here, and then include it in our post request. So the first thing that we really need to do before we log in is get CSRF token from login page. And the way we're going to do that is by performing the get request to the login page, which is this one over here. So the URL to the login page is this. So we'll say login URL is equal to URL plus /login because we're getting it from over here. And then we're just going to create a new function. So we'll just say CSRF token is a variable that is equal to the output of the function get CSRF token, and that takes in the session object and the login URL. So instead of implementing the functionality over here, we're just creating a new function and getting the CSRF token from there. So rest of code. All right, let's implement that function first. So def get CSRF token. We're going to perform the request. So s.get URL verify is equal to false because we don't want to verify TLS certificates. And proxies is equal to proxies because we want our request to be sent to burp. And then we'll say soup is equal to beautiful soup, r.text, and HTML parser. So we're just parsing the response, and I'm calling the beautiful soup function over here, but I didn't import it. So let's import it. So from BS4 import beautiful soup. All right, this looks good. Next we're going to say CSRF is equal to soup.find, and it's where the CSRF token is stored. So if we look over here, it's in an input element under the name CSRF, and the CSRF token is in the attribute value. So the way we're going to extract that is we're going to say it's an input element, and the name of the input element is equal to CSRF, and what we want is the value parameter, because that's the one that contains the CSRF token. Okay, this looks good. Next, we're going to return the CSRF variable so that it gets sent to this right over here. Okay, this looks good. Now that we've gotten the CSRF token, we have all the variables that we need in order to log into the account. And so the first thing that we're going to do is log in as the Wiener user. So let's print that over here. And we'll say logging in as the Wiener user. And we need the parameters to log into the account. So we'll call that data login. And if we go over here, you could see that it takes in 3 parameters. So the CSRF token, the username, and the password. So we'll start off with the CSRF token. And then we'll add the username. And the password, which was Peter. Okay, this looks good. The next thing to do is perform a post request. So we'll say s.post, and it takes in the login URL and the data in the request, which is data login. Set verify to be equal to false, and proxies to be equal to proxies. And we're going to set the response to a variable called res. And in order to confirm that we've actually logged into the account, we're going to search for the string logout in the response. And if we get it, that means we've successfully logged in as the user that we were given. Now, if we don't see logout in the response, that means we failed to log in. So we'll add a statement for debugging purposes saying could not log in as the user that we were given. Okay, so let's assume we logged in as the user. The next step is to exploit the access control vulnerability. And access the Carlos account. And the way to do that, so if we go to my account over here, and we did this in repeater. So if we go to repeater over here, this is the request that we made. It's a GET request, and it's to this URL right over here. So we're going to call this Carlos URL and copy this over here. And then we're going to perform the GET request. So s.get Carlos URL, set verified to be equal to false because we don't want to verify TLS certificates, and set proxies to be equal to proxies because we want the request to be sent to burp. And then we're going to save the response again in a variable called res. And what we're going to do is we're going to check for the string Carlos in the response. The reason we're doing that is just to confirm that we've successfully logged into Carlos's account. And if we did, we're going to print successfully accessed Carlos's account. And then we'll print another statement saying that we're retrieving the API key. Okay, so the next step is to retrieve the API key from the response. And so what we're going to do is we're just going to run a regex string on the entire response and extract the string that starts with your API key. And so it should extract this entire part right over here. So to do that, we'll create a new variable called API key. And then we're going to say re.search. So search for the string your API key is, which is this string right over here. And then match on any number of characters. And do that for the response. And then I'm going to say .group1, so output the first element. Okay, so this looks good. And then we're going to print the API key. So API key is, and we'll add the variable right over here. So API.key. And we're going to add a split statement, and I'll explain that in a bit. And we're splitting on the div element and just outputting the first instance of it. So what happens when we search on this regex right over here is that it will print this entire string over here. However, I just wanted to print the API key. And so what I'm doing is I'm splitting on this element over here and then outputting the first instance. And so what it should output is just this string right over here. Okay, this looks good. Now let's assume Carlos was not in the response. That means we weren't able to successfully exploit the vulnerability. So we'll print could not access Carlos's account, and we'll output the program because the exploit failed. And if you notice over here, I also have a missing exit statement. So sys.exit -1. Okay, let's save this. This looks good. So if we go back and review, essentially this is the main function. It takes in 2 arguments, the name of the program and the URL. It starts a session object and then calls the function Carlos API key. In that function, the first thing it does is it extracts the CSRF token from the login page. And the way it does that is by calling the function getCSRFToken. Next, it uses the CSRF token and the regular user credentials that we were given in order to log in as that account. After it logs in as that account, it exploits the horizontal privilege escalation vulnerability in order to access Carlos's account. Once it has access to Carlos's account, it retrieves the API key and outputs it on the screen. Now, hopefully we don't have any errors. So if we go to terminal, new terminal, and I'm pretty sure this timed out. And it did, so let's open a new instance. And then we'll say Python 3 access control lab07.py. And we copy this. And we'll just wait for it to load so that the program can run correctly. Okay, let's hit enter. And it says name request is not defined, and I did mean requests. So if we go to line 61, and this should be requests. Let's save that, clear it, run it again. Okay, so far so good, and we get an error. So this is definitely wrong, so we missed something right over here. And I know what it is. So Carlos's URL is the regular URL plus this endpoint right over here. So again, let's clear and run it again. And we get another error on line 58, and that's because I programmed this really quickly. So we've got Carlos API key, and then that goes to line 42. And this should be API underscore key, because that's the name of the variable. Hopefully this is the last error. Again, hit enter. And here we go. It outputs the API key. So if we go to burp right over here, you could see all the requests that it made. The first thing it did is perform a GET request, retrieve the CSRF token, and then it used it in order to log in as the regular user that we were given. And then it performed the horizontal privilege escalation vulnerability to access Carlos's account. And then from there, it retrieved the API key. So if we copy this, and submit the solution. Here we go. It says, congratulations, you solved the lab. All right, so we successfully completed the exercise by first exploiting the vulnerability manually and then scripting it in Python. In the next couple of labs, we'll look at more complex cases of broken access control vulnerabilities.